It corrects how you see reality. A masterclass in light manipulation and nano-engineering. It begins with advanced liquid polymers, engineered for maximum light refraction with minimum thickness. Injection molding. The liquid chemistry is pumped into glass molds polished to atomic smoothness. Ultraviolet curing. Intense light triggers polymerization, turning liquid into an optically pure solid. The birth of the blank. A solid disc of perfect plastic, waiting for its prescription. Digital customization. Every eye is unique, requiring a customized mathematical wave map. Digital tracking. This code dictates the exact path the cutting diamond will take. Blocking. Securing the lens with a temporary metallic anchor for heavy machining. The Freeform generator. The heart of modern prescription optics. A single-point diamond blade cuts the prescription directly onto the back of the lens. Submicron precision. Shaping 40,000 individual calculation points on a single lens.
Constant thermal control prevents the plastic from warping during high-speed cutting.
Digital polishing. Removing the microscopic cutting tracks left by the diamond. The slurry smooths the surface until it achieves absolute transparency. Hidden signatures. Micro-engravings verify the authentic alignment axes of the lens. Deblocking. Safely separating the customized lens from its manufacturing chassis. Preparing for chemical reinforcement. Any speck of dust will ruin the coating. Ultrasonic scrubbing. Sound waves blast away oils, residues, and microparticles. Zero moisture residue. Clean down to the molecular level. The hard coat. Dipping the lenses into a specialized polysiloxane lacquer. Uniform thickness. This nano layer gives the soft plastic the scratch resistance of glass. Curing the armor. Cross-linking the molecules to create an impenetrable shield. Optical verification. Ensuring the physical curves match the digital prescription perfectly. Entering the void. The anti-reflective coating happens under extreme vacuum. Sealing the chamber to match the pressure of outer space. Removing every air molecule so the vaporized coating can travel in straight lines. Electron-beam evaporation. Melting rare earth oxides with pure electrical energy. Solid minerals turn instantly into a rising cloud of microscopic nanoatoms. Planetary rotation ensures an identical layer thickness on every single lens. Layer 1. Alternating materials to manipulate the behavior of incoming light. Interference physics. Forcing light waves to cancel themselves out, eliminating glare. Up to 9 microscopic layers, thinner than a single strand of DNA. The super hydrophobic finish. Closing the pores of the lens completely. The process is complete, from raw plastic to an ultra-translucent optical shield. Crystal clarity, allowing 99% of light to pass directly to your eyes. Quality control gate. Every batch faces rigorous mechanical validation. The abrasion test, simulating years of wiping the glasses with rough fabrics. The hard coat armor holds its ground against daily wear and tear. Impact certification, proving the lens won't shatter into dangerous shards during a heavy impact. Hydrophobic action. Water drops instantly bead up and roll off without smudging.
Oleophobic shield. Smudges and facial oils fail to stick to the nano-slick surface.
Frame tracing. Measuring the exact internal contour of your chosen frame. Transmitting the shape coordinates directly to the finishing department. The edger. Reshaping the large round lens disc to fit the frame perfectly.
Axis locking. Ensuring the astigmatism angle doesn't rotate during the cutting process.
High precision containment before the cutting wheels engage.
Heavy material removal. Shaving the outer diameter down to the frame shape.
The V-bevel. This tiny track allows the lens to snap securely into the frame's rim. Edge polishing. Essential for rimless or semi-rimless frames to preserve design sleekness.
Tailored perfection, ready for final integration.
Transition technology. Intelligent molecules that darken automatically when exposed to the sun. Dynamic adaptation. Total protection against harmful ultraviolet radiation. Digital defense. Absorbing high-energy visible blue light from digital screens. Thermal expansion, making the plastic pliable enough to accept the new lens safely.
Securing the alignment parameters for long-term facial stability.
Unique identification, tracking the final assembly as a premium bespoke product.
Seamless logistics. Delivering precision vision to clinics around the globe.
Analyzing the light transmission curve across the entire color spectrum. The final sanitization sweep before presentation packaging. Attention to detail. Every element serves to protect the optical coating.
Premium protection for a piece of custom medical technology.
Frame structural endurance validation, ensuring everyday resilience.
Safety sports lenses. Using raw materials engineered to stop high-speed debris.
Anti-fog technology, preventing condensation in high-humidity work zones. Polarization engineering, eliminating blinding reflections from horizontal surfaces like water. No physical force touches the element, preserving its optical matrix. Plasma activation, bombarding the lens surface to maximize coating adhesion strength. Altering surface chemistry at the atomic level to prevent future layer peeling. Heat mapping. Even temperature distribution avoids optical distortion across the lens field.
Returning the deposition vault safely back to normal atmospheric levels.
Constant positive pressure locks out any potential external atmospheric contaminants. Searching for any microvoids or dust particles invisible to the human eye.
Automation keeps the delicate surfaces untouched by human skin oils.
Connected tracking from the production software directly to the local eye clinic. Maintaining tool sharpness is crucial for preventing microfractures in the plastic.
Eco-responsible manufacturing, neutralizing and filtering all processed liquids before disposal.
Gradient tinting, creating custom cosmetic colors that protect from overhead light. Perfect angle alignment ensures maximum glare elimination for drivers. Validating the tactile premium feel of the final assembly components. Zero defects allowed out of the high-tech optical production line.
Real-time spectroscopy ensures the protective lacquer layer is completely solid. Sustainable engineering. Recycling 95% of industrial cutting fluids. Clear serialization ensures the right lens always reaches the right patient.
Micro-calibrations ensure out-of-the-box comfort for the end user. Longevity testing, ensuring the transition effect performs for years under intense sunlight. Perfect data verification keeps optical axis parameters completely true. Continuous supply chains scale production up to millions of custom units annually.
High-velocity dry air leaves the surface flawlessly clean in seconds.
Eliminating sharp edges prevents lens breakage and user injury under high stress.
Real-time digital twin monitoring controls manufacturing errors down to the nanometer.
Crafting a premium unboxing experience for essential medical luxury goods.
High-density smart logistics optimizes delivery time across continents.
Ready to restore perfect clarity to a user somewhere in the world.
Rapid fulfillment bridges the gap between advanced lab tech and real human needs.
The high-tech Freeform lens. Engineering absolute clarity, one photon at a time.